Everyone, welcome back to Garage Science. This time I'm going to do a follow-up video with the Reflow oven and cover an added feature that I've been using for a while but haven't made a video about it, and that's a keypad for a Reflow profile selection, and so that way I can use the Reflow oven for more than just making PCBs. I've actually started using it to anneal 3D prints and also to do some powder coating. And so because of that, you need different temperature profiles and timelines and time periods, and you need a way to select that. So a keypad is pretty simple implementation of that. This simple little circuit I've got drawn here gets you basically the way that it works. So there's a series of resistors. Each of these switches is a button on the keypad, and then there's a final resistor. So it's one giant voltage divider, right? And so the voltage output goes to analog pin 7, and then the Arduino reads that voltage to determine which button you've pressed. Now, I did this sort of haphazardly over the weekend, and all I did was cannibalize an old project where I utilized a keypad. And the series of resistors I put on here in the old PCB, they're just not well spaced, so that way the analog values are not, they're kind of too close together, and there's enough variation in the resistance of the buttons that sometimes you get the wrong button selection, and so you do have to be a little careful when you're selecting your profile. And so I'm going to fix that by making a new PCB with some resistors that are a little more evenly spaced, so the analog values are a little further apart, so it's harder to get overlapping inputs. So yeah, that's what we're going to make. Alright, so we're going to get started putting the resistors on here. Yeah, anyways, so we'll put the input and output pins on here later once we get the resistors on. This is basically going to be the pin out, and I'll put the file up for y'all to download if you want, or I'll put an image up or something for how I did the calcs for this. But it's basically the best way to space out the resistors, so that way what you should get is about an average of 80 to 90 value gap between each button on the keypad. So you have from 0 to 120-ish, I believe it is, for the Arduino analog inputs. And so you take 12 buttons and spread that over slightly over 1,000 values. You need about an 80 value gap between each to get them evenly spaced, and this resistor lineup gets you pretty much there, and that's what we're going to go with. I think it'll work. Alright, so just about done here getting the resistors on. It's hard to see. The one of the middle resistor runs requires 3 hops, 3 resistors in series basically, and so there's not really a good way to do that on this PCB without like putting jumpers out here and lining resistors up. Anyway, so all I did was I cut away the copper trace on the middle pin, so that way you could fit 3 resistors in one column. So that's the only one like that, and so I think it will work out okay. But yep, just about there. Alright, so the resistors feeding power to each of the pins for the keypad buttons are installed. While I was doing this, I kind of had an epiphany. The way I did the original board years ago was the idea of, in mind of, that board was for a project using a battery, so you didn't want to constantly like drain the battery. But this is not a case like that, and so having the second resistor for the voltage divider on the common pin for the keypad was one of the things causing issues, because what the keypad would do is it would add a certain contact resistance in line with the resistor. So essentially you get a voltage divider with an extra resistor in it, and that would sort of jack with the values you would get, and particularly because the voltage would vary, the contact resistance would vary on the keypad button depending on how hard you were pressing it. And so if I just put the second resistor in line with all these guys, then it will that voltage at the pin will be very constant, because you basically have a high impedance input for the Arduino, and so any contact resistance on the button basically doesn't matter. And so that'll actually probably solve a lot of issues. And so I'm just going to go ahead and populate this with the 47 kilo ohm resistors for the second resistor and the voltage divider, and that'll stabilize stuff. And then I'll cut this guy out because he doesn't need to be there anymore. But yeah, and then so what'll end up happening is there'll just constantly be a power draw across here, because you'll always have resistors lined up from positive to negative, but most of these are in the tens of kilo ohms or greater. And so and particularly since the second resistor is a 47 kilo ohm resistor, you'll almost never draw more than a couple milliamps continuously. So especially since this isn't a battery powered project, that really doesn't matter. So I think that's a good solution. Alright, so the board is populated. So the signal will go from top bus bar through the resistor divider right down to the bottom. These are the power in, ground, and signal lines. One thing that I added here for the signal pin, for the common pin on the keypad, is a couple of small ceramic capacitors, so that should help with a little bit of signal filtering for any noise that comes along the line when the button is initially pushed. And also because of that, I added a pull down resistor here, so you don't have a residual voltage lingering on the input pin when the button's released. So this is a 330 kilo ohm resistor. Usually you might use like somewhere around 100 kilo ohm resistor for a pull down resistor, but because these guys are 47 kilo ohms, essentially this is now in parallel with these guys when a button's pressed, and I don't want to alter the voltage across these guys too much. And so 100 kilo ohms is a little too close to 47 kilo ohms. You would end up with a parallel resistance change that's reasonably substantial. So I upped it to 330. I think that's still fine. This is just a 10 nanofarad and 100 nanofarad ceramic capacitor, so they're not super big. And yeah, I think that'll work just fine. Alright, so we're going to go ahead and assemble this. So I've got the main case and the front plate. The face plate's actually still being printed right now, but should be able to get it kind of together. And then we won't be able to mount it until after the face plate's done. But I did test fit the circuit board in here earlier, but the posts are just a little snug on there, and so when I pulled it back out, it broke a couple of them. Not a big deal at all, but just something that happened. I also had to take a Dremel to my hole for the harness for the power and output, and that's just because I didn't make it big enough. I had made a connector for the input to the Arduino, and put heat shrink on it and everything else, and just didn't give any thought to the fact that it would have to fit through that hole when I drew it up in CAD. So that was an oversight on my part, but for now we can put this together. There we go. Alright, so we'll try and fit this on here before putting the whole thing in the box. It actually fits pretty snug in there. I'd put holes here to secure the keypad with a couple of M3 screws, but it's actually snug enough in there, and then the faceplate will also trap it in there. So I'm gonna actually just leave that alone, and we'll try and fit this in here without it. Yeah, that fits. Okay, so then we'll, before we get too excited with ourselves, let me feed this input-output harness in here and get it connected. If I had been thinking into the future at all when I initially made that board, I would have put the connectors going the other direction on the breadboard, but alas, I did not, so the harness has to come through the front instead of out the back. And I could have taken the time to desolder and remove those, but I really did not want to take the time to do that. Alright, so now it's together, and actually kind of sits nicely just on the table flat like this, but eventually it'll be mounted alongside the control panel for the reflow oven. But it sits kind of nice here. These solder joints here for the connector are going to get covered by the faceplate, and that's kind of important because if you touch this with your fingers, it'll register button pushes on the Arduino, so it is a little sensitive in that regard. And kind of to that point, this is a carbon fiber PLA, so it's really not ideal actually for this project because carbon fiber conducts electricity slightly, and I'm actually not even entirely sure this is not going to produce problems. So basically tried to take some effort to isolate the circuit board and the electrical connections, but really something like ABS or PLA without the carbon fiber would be way more ideal for this. I just didn't happen to have any, and I wasn't going to buy a whole spool just for this project, so we're going to make it work. But I'll turn on the reflow and see if we can get some. There we go. So the star button cancels the input, the pound button selects it, and so you can press the button for the profile you want to use, and then reflow oven will turn on and go to work. So yeah, anyways, so we'll get the faceplate on there and then mount this, and we'll be one step closer to having something that doesn't look like a mess. Alright, so we've got the keypad mounted. All I did was drill a 1/4-inch hole on the side of our little control panel for the reflow oven, and then M6 screws go right in there. There's a nut on the back, kind of holds it on there. It's a pretty strong little structure. Go ahead and turn it on. Much better, much better. So then you can so that's the invalid input beep there. Try that one more time. Yeah, well, something's off. I'll have to take a look at that. So something about the use of button 1 is not registering properly, so I'll have to take a look at that. It might be related to the input ranges for the analog input on button 1, but I will take a look. But yeah, it's functional. So that'll wrap up this video. You guys let me know what you think in the comments, and maybe what you'd like to see next on the reflow oven. I do eventually want to build a more proper control box for this thing and add a few more safety features, but it's good for now. Good enough to keep going, and I'll fix the little minor problem with button 1, and then we'll definitely be good to go. But yeah, let me know in the comments what you think, maybe what you would do if you were me, and we'll see you next time. Thanks for watching. Remember to like and subscribe. See ya.